So I think maybe we'll go ahead and get started, and we'll let people trickle in. But first of all, my name is Nick Raboy. So I'm a developer evangelist at Here Technologies. We do have a booth out there. This presentation is under no circumstances related at all to what I do at Here Technologies. So this is more of a hobby project of mine. But the focus is going to be developing an API, but using a more modern approach, so using GraphQL. It's going to be with Go, and then we're going to use NoSQL in the mix as well. And because I think it is being recorded, let's go ahead and save the questions till the end, so that way they don't have a hard time editing anything that comes. So before we take a look at why should we even bother using GraphQL, let's take a step back and look at the REST API approach. So a lot of you might be familiar with this, and is this visible? Do we need to turn off a light maybe, or it's good? Yeah, so a lot of you might be familiar with something like this. This is a fictional API. I know there's tons of APIs out there for Pokemon data, but let's just, so that way I don't bash anyone, this is a fictional API. You can access it with curl, and in theory, when you make a request to this API with HTTP, you're going to get an array back with whatever data exists for a particular Pokemon. And this could be very lengthy, it could be very small, it could be however this particular API endpoint was designed. Then there's more of an alternative approach, same kind of end goal here of getting the Pokemon data. But in this approach, with REST, we've now chosen to split up each of the API endpoints. So in this circumstance, we have this kind of core API endpoint for Pokemon, but we're getting the very bare minimum in terms of data when we make a request. But the important part of that would be the ID, so that way we can go and do requests to the other paths for the rest of that data. So as far as anyone who's used a REST API before, how many people have seen the first approach, where you're getting a massive amount of data back in a single request? And then how about the second approach? You've probably seen that as well, right? I've seen some APIs where there's like more than 100 API endpoints. They are very similar in what you get back, but there's just so many of them. Some of them are well designed as well. So in both scenarios, there's nothing wrong with this approach. This is classic REST API development. But that doesn't mean that things can't be improved or made better in the process. So some of the problems that I have with the REST approach is, one, there's a lot of API endpoints to remember. So if you're a developer and you're looking at an API and for some reason that API does have, say, 400 endpoints, that can turn into chaos for your application. If you're a developer and you've developed this API, well, now you've just developed 400 API endpoints, and now you've got to maintain all of those API endpoints, which is also kind of a pain in the butt to do. There could potentially be a lot of data to process. So if you're using the scenario where you have multiple API endpoints that you're picking and pulling, they're smaller ones, like the second slide that I showed you, well, now there's a lot of data to process. So your front-end application may have to parse that data, may have to do manipulations to make it usable. Or in the event where you're using the very large API endpoint, well, now your payloads are very large. You have to worry about what your network latency is going to be, how much time it's going to take, things like that. So that's kind of where GraphQL spun out of things. So with GraphQL, and this is just taken from the GraphQL website, these are my two favorite points of GraphQL. But one, GraphQL is a query language. So with GraphQL, you're able to query your APIs now. Instead of making a request to your API and just consuming whatever it might return, you're now querying it for only the data that you want. So you can pick and pull, you can decide how large of a request you want to make, how small of a request, and you're doing so in a single request. So you can get as many resources as you want, as defined by a query, in a single request. So typically, if you wanted to get maybe unrelated data, you would have to do X number of requests to get that unrelated data. With GraphQL, you just make a more complicated query, but you can get all of that data, regardless if it's related or not, in the single query as a response. And there's other reasons and benefits why GraphQL is valuable, but these are two of my favorites. I don't think I can. This is a slide. This is taken directly from GraphQL.org, so it's nothing that I've created personally. The future slides should be more readable. They should be larger. rather than screenshots like this. So for example, is this a little more readable? Yeah. So this is an example of what you could do with GraphQL. So we're taking a look at that Pokemon data again. Instead of using REST, we're writing a query on the left. We're saying, you know what, maybe this query is called Pokemon. And we're saying, you know what, we only want the ID, the name, and the moves back. Based on the first slide that I showed you, there was potentially other pieces of data that could have come back in that request as well, right? We could have had attributes, maybe a height or a weight, things like that. But we've chosen only to supply those particular properties. And you'll notice that that query looks kind of like JSON, but without the value. So it's just the properties. And on the right, that's the data that we got back. It's exactly what we requested. Now, I alluded to this earlier. You could have unrelated queries, data that you're requesting in a single query. So in this example, we have the Pokemon query again, but we also have an item query. This is the same query, but we're asking for two separate pieces of data back in the same request. And in this case, for item, we're also specifying user-defined properties or parameters that we want executed in the process. So we're saying, you know what, give me an item, a particular item, where the ID is value of 4, and give me only those properties back. And that's what we'll get back as a response. So it's very clean in the approach. So just kind of a recap before we get into some Go code here. When it comes to the server and client payloads, they're very flexible. You can define exactly what you want back. You don't have to get massive amounts of data back, which will make your applications faster. The queries are going to be flexible. And then even though you could consider that the trade-off between remembering all of these API endpoints is in trade for remembering all of these different queries that you have to remember, in theory it should be a little easier because those queries should be more descriptive of around the data that you're requesting. And I'll show you that as we progress. But those are some highlights as of now. Now we're going to get into the Go side of things. So raise of hands, anyone actually use Go in here? Everyone else, this is your first exposure to it, or maybe read about it a little bit? Perfect. So when it comes to getting started with Go and GraphQL, the first step is you need to download a Go package that'll allow you to start with development. You could easily make your own, but the convenience of it is you might want to use one that already exists. So a popular one would be the GraphQL Go package. There's others. This is the only one that I've played around with. But you would say go get, which is your package manager, and get that particular package. Once you have that package, and I realize this is a little small, I'm going to read it out to you. It shouldn't be too much of a burden, it being small. But when it comes to defining what you're doing in Go, you have to create a native Go data structure, which would be the data structure in Go and the properties that you're after. But in addition, you also have to create a GraphQL object. And in theory, these two should be kind of the same, but just in a different syntax. So in the example of Pokemon, we've referenced the fields that we would expect based on my previous queries. So for example, we have moves, which would be a slice of move, which is the other native Go data structure that I have on the right. We have string values. And then for the Go GraphQL object, we have a string. We have, in the case of a new list, that would be the same as a slice. So a new list of, say, move type, which is in turn the GraphQL object as well, which relates to the native Go data structure. They're connected through the JSON annotations that you assign your native Go data structure. So for the example of Pokemon, I have annotations, and those annotations are used not only for the GraphQL object, but when it comes to marshalling our data as a client response, it'll automatically marshal that data for us as well. Similarly, you'll have a GraphQL query. It too will be of the type GraphQL object, just like we saw with the data structure or the model of our data. This is an example query. We're naming it root query. It could be named whatever you want. It too has a name. It also has fields. In the previous example, the field represented the property of the data. In the query example, it represents one of many possible queries that you can execute. So in this case, our query is called Pokemon. And the type that we wish to return from that query is going to be a list of Pokemon type. So it's going to be a slice or array of Pokemon type. What really matters here is the resolver function. So this is where our logic comes into play. So with the query, we add a resolve function, and that's how we connect to the database or do any kind of logic or manipulations to return data. And in this case, for now, before we get any kind of database interaction involved, we're returning just an empty slice of Pokemon. And we're assuming that this Pokemon is plural, so we're going to return multiple. Now let's look at this query. I know I named it the same, but let's say that this is the singular version. Let's go ahead and say that even though it won't make sense, the previous query is Pokemons. This one will be Pokemon singular. In this case, we have the option of returning a Pokemon type rather than a new list. As for we can add arguments. So if we wanted the user to add data to the request, we could add arguments. In this case, a possible argument is the ID. We're making it required, hence the new non-null, and it's going to be of type string. So it must be a string, otherwise you'll get an error when you try to execute this query. Then the resolver function comes in and runs our logic. Even though I didn't actually use the argument in this example, I could have, and I will. But for now, we're just saying, you know what, return us a Pokemon type. And it's going to be empty. And if I wanted to run any of this, it would look like this based on what I've designed. So hold on. So in this case, I made a Pokemons query. I've decided, you know what, that's the data that I want. I've also created a query called Pokemon, and I've given it an ID, which was expected, of type string. And in theory, it would give me back data based on my demand, even though it doesn't do anything as of now. Now that I have a query and I have some data models, I do have to wire up a schema with GraphQL, which is very easy. You just create a new schema object, and for the property of query, you tell it which GraphQL object is going to represent our queries. So in this case, we've called it root query. And this is a read-only query. We're going to get into mutations, which will be not read-only. They'll be write as well. But for now, it's read-only, so it's a query. Just because it's GraphQL doesn't mean that you won't have HTTP endpoints. You'll have one. So in this case, I'll create a HTTP endpoint called GraphQL. And when this request is made, we're expecting that a query be passed in the request. In this example, the request is a query parameter. In reality, you probably might want to do a post request, like a post body. But in this example, it's just a query parameter. We're executing the GraphQL query. We're using the schema that we defined. We're using the data that was passed. And then we are encoding the result into JSON. And we're listening on that particular port. If we wanted to run what we've done so far, we could very easily use a front-end framework. We could download some dependencies. We can do whatever's available for GraphQL. We could do curl. We could use the prototyping tool that GraphQL offers, which is called Graphical, which is GraphQL with an I in there. And that'll allow you to prototype your APIs. And you could always disable it for production if you wanted. But in this case, I'm saying, you know what? I want to do a curl request against our GraphQL endpoint. We have our query parameter in there, and I'm just passing in the GraphQL query that I want to execute. So nothing too bad so far. Now we kind of want to work with real data. Returning fake or mock data or empty data probably isn't very useful to us. So now we want to get a database involved. And full disclaimer, so I'm going to be using the database called Couchbase, which is an open source NoSQL database. I also used to work for Couchbase, but you can apply some of the same logic towards any other database. It's going to be more or less very general. But as far as a brief background on what Couchbase is, so Couchbase is a platform. There's three specific parts to this platform. There's a Couchbase Lite component, Couchbase Server component, and then a Couchbase Sync Gateway component. In terms of the Couchbase Lite component, Couchbase Lite is an embedded NoSQL database. So typically you would have this for iOS, Android, or some kind of IoT application or desktop application. Some kind of client application as a drop-in replacement to, say, SQLite or similar. Then there's Couchbase Server, which we're going to focus on for the examples of the Go code. This is a distributed NoSQL database. So you're working with nodes in a cluster rather than a single database that you scale up with hardware. This is a document database, so you're going to be working with JSON data. And it's designed to be very fast because it has caching and persistent disk as all in one. So it makes it very quick. And then Couchbase Sync Gateway, which is the third and final component here. So typically when you have a embedded or client-facing application, you don't want to have that interact directly with your database server. That would be bad. You'd open yourself up to a whole lot of security concerns. So what you want to do is you want to have a middleware component, and that's what Couchbase Sync Gateway does. Your Couchbase Lite component communicates with Couchbase Sync Gateway. It has your authentication and authorization rules, and it communicates with Couchbase Server and decides which data goes where and who has access to that. So it is the middleware component. You could use one, you could use two, you could use all three of these components. It doesn't matter. It depends on your use case. But we're going to just focus on Couchbase Server. Now, kind of one of the few last slides on the overview. In case this is your first exposure to NoSQL, this on the left is a relational database model. Back in the day, I've done way more relational database work than I have NoSQL, so it may look more familiar to you if you're in the same boat. But let's say that we have a list of columns, and rows, and tables of data. Let's say that maybe it's kind of a user board for like LinkedIn, where you have your skill data. Typically, when you want to view this data, say on LinkedIn, it all gets displayed at once as your portfolio page. Typically, you wouldn't actually retrieve any of that data alone. You would get it all together. So when it comes to modeling it as a document database, you have options. One option in that scenario would be maybe just store it all into a single document. So that way, in the future, instead of having to do join requests or anything like that, do one request, a key value lookup, get that data. It's very fast. If that's not suitable for you, you could, in fact, you could split it up into what's called a referred approach. And you could create a new document, a new JSON document for each of the possible pieces of data. And then you could use, similar to a concept of a foreign key and primary key relationship, except for your database isn't going to define those constraints for you. You're going to have to manage that through your application layer. If you install Couchbase, and this is, I'm going to bring this all together here. If you install Couchbase, this is what you get out of the box. You get a web dashboard. In the web dashboard, you have access to the server health as far as what services are available, things like that. In terms of our application, what we're going to need, though, is we would need a user account. We would need to create a user account so that way our application can access certain parts of Couchbase and not just the whole admin user, because that would be very poor design if you allow an admin user or one user to access all parts of your database. So in theory, maybe we create a user called example that has access to read, write, and query. Once we have that, we can look at how our data might look like in the database. And I realize it's a little small, it's a screenshot. But in this example, this is the same data that I showed you in the first slide with that REST API, potential Pokemon data. In this example, it's stored in what's called a Couchbase bucket, which is a collection of NoSQL documents. Usually you have one bucket per every one application, and that one bucket can have any number of different types of documents. So if I wanted to, I could have Pokemon in that bucket, I could have items in that bucket, I could have games in that bucket, I could have anything in that bucket. So in this case, I would create my user account, give it permission to that particular bucket, and I'd give it permission to be able to use that information. If I wanted to query that information, I can use a SQL dialect here. So this would be very similar to what you would see in MySQL or Postgres or things like that. Couchbase does have its own programming language, database query language. It's called NCL. It is an ANSI compliant query language. So it would be very similar to see what you would do in those other languages. So quick overview on NCL before we get into actually using it in the application. So it's a non-first normal form query language. Like I said, it's ANSI compliant, so you're not going to get bits and pieces of what you would see in traditional SQL. You're going to get all of it. It's going to have its own little flavor to it, just like MySQL is slightly different than Postgres and things like that. It'll be similar. But you know what? It's an extension to regular SQL. So it's designed to be able to work on nested data. So typically in a document database, you have nested objects, and maybe those objects have arrays in them and more objects. You need to be able to accommodate that with SQL. You also have to be able to accommodate being able to work with distributed data. So with MySQL, it's possible, yeah, you can wire up your database so that way you can have a cluster of MySQL databases and you can query for them. In Couchbase, it was designed to be very easy so that way you don't have to mess with all the nonsense. As far as being expressive, so like I said, every part of that document, you can run subqueries to get to that data. You could run aggregate functions, things like that. As far as being familiar, you have, again, every part of what you would expect. A SQL statement, a select statement, you could do insert. You can even do a query plan. So not a lot of people are informed about query plans. They exist in most databases. But if you ever want to kind of profile your queries and see how they're running, how you can improve them, you would do an explain. It would give you a query plan. It would tell you what indexes are being used, how things are performing as far as speed. And then you can go ahead and modify them to make better queries. So that kind of stuff still exists. Being feature-rich, there are custom functions that exist. So for example, if you're working with array data, it might make sense to unnest that data, so that way it would flatten that data out. Or you can go the other direction and work with it and turn array data, unnested data into nested. Or you can work with array data as is, and you don't have to alter it at all. So there's other commands. You even have access to join. In a more realistic scenario, this is more related to our data. In this case, we would say, you know what, we want to select the name of the Pokemon from our bucket called example, where the type property inside of those documents equals Pokemon. Because in one of the previous slides, and I know it was very small, there was a type property as far as the data goes, and that's how we're able to index this data. So if we ran this, and maybe I had one item in the database, it returns the name instead. Now to use that in Go, again, we need to get the dependency. So we need to use our package manager, which is go get, and we need to get the Couchbase dependency. Once we have the dependency, we need to establish a connection to the database. So first of all, we need to establish a connection to the cluster. In this case, let's assume that my cluster is running on my local computer. Once I establish a connection to that local cluster, the SDK and the application become aware of every other node in that cluster because it's a peer-to-peer database. So once I establish a connection, if this node goes down, it's going to be fine as long as you have other nodes that's still connected to. If for some reason that node is down when you try to spin up your application, you can actually provide multiple nodes to connect to, delimited by commas, to give you a more balanced approach to connection. Depends on your needs. You'll authenticate with that user account that we in theory created. I've called it example. I've provided a password, which you'd probably want not hard-coded in your application, but it's there. And then after you've authenticated to your application using that account, you would open up a particular bucket. In this case, it's just coincidence that I've named the bucket example just like the username. They do not need to match. But just 3 lines to get a connection to the database. Now we look at our queries again. Hopefully they're not too small. But these are our 2 queries that we saw previously. But now they actually have stuff in them. So in the example of Pokemon's plural, what we're doing here is we're saying, you know what? We're planning on returning a slice of Pokemon. So we're constructing a nickel query. We're saying, in this case, we're just using the asterisk. We're being lazy here. You can provide every property that you want. That's probably the best way to do it. But we're creating this nickel query. We're executing it. And then we're looping through each result in the result set, adding it to that slice. And then eventually, after GraphQL is done, based on the runner that we have in our endpoint, it's going to encode that as JSON and return it back to the user depending on what they've responded with. And likewise with Pokemon, singular, we have our argument, the ID. In this case, I'm not using a nickel query. I'm saying, you know what, I'm going to create an object called Pokemon. And I'm saying, you know what, this time I'm going to do a key value operation. We're expecting that an ID be passed. So I can do a key value operation, a key value lookup. I can say bucket.get. Let's say that maybe I've prefixed my keys with Pokemon, and then I'm taking the parameters that was passed, so the args that was passed, that single ID, I'm using type assertion to turn it into a string, and I'm storing it in that Pokemon variable to be returned. I could use nickel. One advantage is if I can do a lookup based on ID, I should, because it's always going to be faster than nickel, because nickel works off of indexes, and while it's not slow, just the alternative is faster when you can use it. Now let's change it up a little bit. Let's say I want to add another data type to our data model here. So in this case, I want to include now what game that particular Pokemon was in. So I'm providing, I'm saying, that particular data is going to include a name, it's going to include an ID. I also have the GraphQL object to go with it. Now there's two ways that I could look at combining this. Let's say that every Pokemon that I have in our database, that one object that you saw from the very beginning, let's say that it now has a string in it called game. That game represents an ID to a particular game. Kind of like you would in a relational database, you're now doing a relationship between your two different data points. What I could do, and I'm going back a slide here, what I could do is in my nickel query, I could do a join. I could do a join based on that ID, and instead of returning a string which may not be valuable to me for a game, I can now fully load that game based on the data of that relationship. Perfectly acceptable. I could do that. An alternative to that is, and this might be a little small, what I could do is I could alter the original GraphQL object from one of the earlier slides. And I could include a resolve function. So the data model and the query, they have the same structure, remember that. They all have a type, they all have a name, they have fields, and they could potentially have resolve functions. So in this circumstance, what I'm saying is I'm saying for game, this game property, I have a resolve function, and I'm going to look at the source or the parent data. So when I say I want to look for the source, I'm saying give me the data from the previous resolve function. The previous resolve function is that resolve function from the query itself. So when I look at that data, what I'm going to get is I'm going to get that string ID from the previous resolve, because I've requested I want all properties from that document, and that includes the game ID. So I'm saying, give me that source. I'm typecasting it. I'm doing a type assertion here as Pokemon, and I'm just doing a get operation on that. So I'm saying, I'm turning that source into a fully loaded game, and I am returning it. Now, the advantage of doing it this way, and again, it doesn't really matter, it's up to how you design, but an advantage of doing it this way is this game will only be executed when you call for it. So if you do a GraphQL query, and that GraphQL query does not include game, as far as what the request is, it's never going to execute this code. That's one advantage. So you're now potentially more lightweight. Another advantage is now your queries, your nickel queries inside of your actual query can potentially be more basic going forward. So you're building much simpler queries, and you are kind of adding the complexity through the resolve function of each of the data models. You don't have to do it that way, but long term, if you continue to build much larger data models, it might be easier to do it this way. Now let's take a look at GraphQL mutations. So as of right now, I've only showed the read-only part of things, so only query. Now we're going to look at creates or deletes or updates. The good thing about that is they're more or less the same. So it's a GraphQL object. You have your name, you have your fields, and for each field, that represents a potential mutation query. We've called it root mutation. Doesn't really matter the name. But we have a mutation called game in this case. In this case, game, we're saying, we're requiring that the user pass in a string. It cannot be null. They're requiring it. And inside of our resolve function, instead of just doing a lookup or a nickel query, what we're doing is we're saying, let's generate a new unique ID for our document key. Doesn't have to be unique. You could hard code this to be anything you want or generate it some other fashion. Let's go ahead and get the argument, the name. We're going to use type assertion to make that a string. And then, we're going to say bucket.insert. We're going to pass in that ID. We're going to pass in the data that was provided to us. We're going to give it a potential expiration time for this document. I'm saying an expiration time of 0, meaning it will not expire. If I wanted to give it something in seconds, that means that the database will automatically remove that document without any kind of user intervention at all. That's more particularly useful for, say, sessions that you need to expire after 60 minutes or something. You can let the database handle that. After we do the insert, we store the ID back in the game variable, and we return it. To wire it up, we go back to our schema that we had previously created. Previously, it just had a query. Now we're adding that mutation. So now GraphQL will be able to handle, well, what's a mutation versus what is just a standard query. So if I wanted to, I could do a query like this. And again, this is just doing it with query parameters. You may want to do a post body. Totally up to you. But in this case, I've changed it a little bit. Instead of saying query as my query parameter, I'm saying mutation now. I'm passing in a mutation, which is, we have a query called game. We're providing it that name data. We're telling it what data do we want back after we've made that mutation. In this case, we want the ID and the name. It could be all, it could be some, it doesn't really matter. If we wanted a more cleaner look at it, that's what the query would look like underneath. It's a little different if you wanted to use, say, graphical to write these mutations. They do have their own structure on what they expect, but it's not too much different from this. Now, I did want to open it up for closing thoughts here, so I do have a summary here. So for one, GraphQL does limit the response payload. So again, as you saw, you could write these queries. They could be lengthy, they could be short. You define exactly what you want because it is a query language. You have your flexibility of your requests. And this is open to opinion here. It does cut down the amount of endpoints that you're working with. I guess in trade, you do have to worry about the amount of queries that you're left with. But in theory, at least in my personal opinion, it should be more easy to work with than having to remember, well, what does this REST API endpoint expect as parameters? What exactly are you getting back? You don't have to worry so much about that. In terms of Couchbase, it's flexible with JSON. It was particularly useful with this example because we had JSON annotations. It played nice with GraphQL. So it kind of made sense versus a relational database. And then it did make it easier with Nickel. If you did want more help on any of this, like I said, that screenshot that I took earlier did come from the official GraphQL website. The GraphQL website is very helpful. It doesn't tell you how to get set up and start building your own GraphQL application with, say, Go or Node or anything like that. But it does tell you the ins and outs of actually using GraphQL and why it's important. You could also learn more about Couchbase. You can follow me on Twitter. That's nraboy. It's not NRAboy, it's nraboy on Twitter. Yeah, I get it. I just have to be clear because some people get a wrong impression. It's my name. Or you can visit my blog where I do have a lot of content as well. I do want to open this up to questions if you do have any questions. Yes, in the back.